Okay, welcome to the VPatch Coder Research Center again, and in today's video I have this electronic card reader. It's a small portable machine that we use to make our bank transactions, and for some reason it's not operative because of let's say the bank automatically disabled it, but our purpose is to investigate uh, and explore what's inside and learn about various electronic that is embedded inside this machine. So here is a connector, you can see, and I am going to take it out for inspection, keep it aside, and then I turn it back. So that's your back side, and this is a very small screw and need a special screwdriver, and since I don't have that, I'm going to use this knife in my test equipment and tools. So I'm just trying to open it. Let's try to open and we'll see how much time it takes. And I have it open now, and I just want to take it out with the hands. I keep it aside and we'll just try to see what's this. So most probably it will be a battery. I don't want to damage the test leads of the multimeter, so I will not use to open the lead here. Instead I will use another tool to open it. So I'm also teaching you the methods to do that. So you see now, I see with the opening of this panel there are different cell batteries. It's made in Indonesia. Manufacturer is Panasonic. There is a positive terminal here, and that's the 3-volt cell as clearly indicated. And here is the notation. Again, I wanted to use the multimeter leads to denote the things, but I don't want to do that to avoid the damage to my multimeter, because this is very high precise instrument and a tool. You don't want to have inaccurate reading or malfunctioning of it. So you see now there is this positive terminal and the negative terminal on the panel, and that's the company website who makes it. And this cell is positioned in a reverse way. So this side is the positive and this side is the negative. So just take it out and we'll see how it goes. So remember, this is the position and here is how it is looking. So first thing first is to check the DC voltages. Right, so remember we had placed this right this way and this is this way. So we'll just take it out and we'll see what we can do. So that is out now. The first job is to test the DC voltage, whether the batteries which offer 3-volt DC supply, if they are proper functioning. So I set the DMM knob to the DC voltage. I have auto here and there is a DC voltage, but I can choose the range. I am going to measure the voltage. So decimal point is before the 2 digits, so I can measure the 2-digit reading effectively. And now I took the cell in my hand. This red goes to the positive and the black goes to the backside negative, and my meter reads 3.25 volts, so it's okay. Next, same positive to the red, this is also 2.30. so batteries are fine, you have no trouble into that. So why don't we just place it back as it was, and here it is like. So the total voltage, oh, I placed it in a wrong way, so make sure that you do that. So what about we just try to measure the effective voltage, positive here and the negative here, and what is the voltage we get here? Do we have any voltage reading? No, of course this is not the way you can read that reading. So they are two individual cells. Okay, and how we know the which side is positive and which side is negative? You see now, if you closely inspect the, it's in the red color. So this flat side without any printing, is the negative side, so that's why they have indicated with this illustration, and this with the positive terminal indicated, and of course the printing side which is your positive, and there are two X means there are two such cells needed. So it's a button battery, that's it. And you see now we are going to close it, and we'll see what's there. But before we close it, here is the pin for the connector, so let's close it. Let me close it. Okay, so after that we just put the screw back here, right here. So well, I have put up the screw here, and now I am trying to open this this unit here from here. So you see now there is a connector just like your computer USB connector. So this is that connection, you can see right here. So this pin we had unplugged this power part, and it can go back, and this goes to your computer. Okay, when you want to actually record and read and extract the information from your bank, you want to see it on the computer screen, you search at your bank statement, your account balance, etc. So this machine is quite handy and helps you do that with the display. You log in, sign in, and put your pin codes and everything, and then you can get everything on your computer screen through this cable. And there is this buy option, like you can make nowadays you can purchase things from your bank account online. So that's the situation there. Okay, so next step is to open this backside lid and see what's inside. So we can see now if we can take this lid out without damaging the machine. So I'm just trying to open it with the tool I have, but it's difficult and challenging. It's not easy to open up the lid right here, so it's going to give me a tough time. So you have to be careful because you don't want to hurt your fingers and also the leads right here, so we have to be careful. So you see now there is a little bit sound that comes, and this is how it goes, and it has to be opened slowly without actually damaging. We might break the we might break the backside the cover also, but we have to make sure that we don't do that. So here we have opened it, and we can see various components and ICs. So here are the resistors, the capacitors. You see the printing on the PC board also. The green is the PC board. So C stands for capacitor, R stands for resistor here. And then there is this diode indicated by D201. So that's how, yeah, this is the processor from the Atmel. That's your another IC from the Google. You can understand what's the data sheet. Here are the two cells that you can see. Here is the one cell, and that's the second cell that is still there inside the battery. So let's take the cell out and we'll see what happens, and this is how it goes. So what was it? And where was it? Okay, so a lot of things are happening. Let me just take out. So here are your two batteries that is out. I don't know where from this part fell down. This was inside this board itself. So nevertheless, you see now, and this is for the connections. And what are these components? These are the transistors, most likely. Let me see what they are. Yeah, T905, that is transistor. Again here is your T901, that is T28, and that is R. So here they are the capacitors. They are SMD devices, surface mount devices or components. They are called SMD components. These two are the resistors. That's the transistor T600. That is again a transistor. This is also transistor Q. So there are two ways transistors have been denoted. These are also surface mount components. Again, these are resistors, capacitor, resistors. These are transistor T and Q. So there are two letters that are used to indicate the transistor. So different types. Now some parts are left, they are not required there, and these are resistors again. So here is a lot of things. You see, this is the modern PCB, and with a packed electronics, so many components and devices, and the integrated circuit is there. So here is a crystal that is indicated by X201, and there are all these are the capacitors. There is a processor IC. I don't know what this block is, X200. So you have to investigate it under the microscope if there is any printing. So most probably it is a sensing unit. I'm not sure. This is also some other IC from the data sheet. You know what can be the number and what is the function. This is a diode, we covered at this, and let's put the cells here and see if it can if there is something that can happen. So how to know which polarity is which? The cells cannot put in reverse way, you have to know the way to put that. So let's go to the button here. So it was like this, and there is this positive side here. So this goes like here like this, and this goes like here. So let the cell go like this, and let this cell go like this, and we'll see if things turn out. So you have to insert the card in order to turn this machine on. Okay, you see now there is some ink spread over here, so you can't really see what processor is that. That's the company strategy. They don't want to disclose their IP. So I think we have covered enough about how the modern electronics board looks like, and we have seen how the surface mount devices are inside with the modern processor, the very fast one. And this is a typical embedded system example that you can understand. You have to open these two screw to see what is beneath and take the PCB out really. And here is your cable connections. You see now there are cable. When you basically put in the card, you actually get the connection through this. Okay, and there you see there are screws here, so you have to really open it fully and to see that. So we can see that. So you now see, since I don't have a very small diameter screwdriver, I am using a knife to open these screws, and it is working fine for me. But you are advised to use the precise screwdrivers with the matching screws. Accordingly you will do that. Alright, so I have taken off all the screws that were in these positions, and what I see now, I am able to take the lead out. So let's have this plastic frame out, and we'll see if the PCB can also be taken out of this board. So we'll just try to see if there is still some connection. There are two screws located right here which I forgot to open, so you need to open them also. So let's do that. Alright, so I have removed those two screws as well, and let me just take the PCB out now. We'll see if the PCB can be taken out. Yes, it's very easy to take the PCB out, and we'll see. And that's your keypad. This is your keypad, how it looks like. So these are the touch switches. Let's turn it back and see the backside portion. So you see this is your display. We can use the display for our embedded application. So this is a fresh display that you can clean with the cloth, and you see now you have this metal tracks which make the connection. So we'll study them one by one, but look at the beauty. This is your modern day electronic PCB with the compact electronics. A lot of electronics is there in a compact form, and it's a dense integration of all SMD components devices. You see that there is like company name also who manufactured it, and this is the USB connector that takes your data from this card. Actually, make sure you don't really touch your fingers to the components and the devices, because it may damage your components. So that is 3.3 volt 3v3. And what is this? We'll see that in a moment. So when you insert your card into the machine this way, actually, or essentially is this way. So this portion, this chip, this portion touches this part here. So 6 pins are there, 1 2 3 4 5 6, and this part touches there. So let's try and do that. Let me just check if it can go there. So I see now there is this which side it goes. So it would be like this. For example, it goes like this. Yeah, it was like this. And there is like you have to make sure, because I have taken the PCB out, so obviously now you have to see which side is positive goes here and the negative goes here, and we'll see if this works or not. Of course it's not turning on, so you have to put it back, all the assembly, and then you have to investigate that. So did you observe that this crystal oscillator connected between these two pins has been twisted in a 90-degree? So it is lying flat on the PCB, because if it is head up, then obviously you don't have a place to fix this, and this is how the smart packaging is done, and you can see that. So look how the display is connected. This is your LCD display, and these are all pins, and from this you can see that these are the pins. I'm not touching with the fingers, I'm just trying to indicate, and you see these are the pins, and this is how the PCB, through the PCB tracks, you are getting the display connected to the rest of the electronics on the PCB. And you see how smartly they have done the hole in the PCB, so that this crystal is being seen from the other side of the front side of the PCB. You see this is bent to the 90-degree, and this is from the back side. So it's quite smart way to do that without occupying too much space. So mainly the crystal is the few centimeters long, and couple of centimeters, the few millimeters long, maybe a 10 millimeters and a couple of millimeters in width. It occupies a lot of space on the PC board. So nowadays there are MEMS technology trying to replace this crystal to provide the stable reference clock to the rest of the electronics, digital electronics. So MEMS technology is replacing through this to in place of this bulky quartz crystal, you have MEMS based resonators that are being used in modern day electronics to provide the clock. So I think we have explored a lot on this modern electronics board. If you have questions or comments, write in the comment section of the video, and we can keep exploring more on this or other boards, and we'll see that this is the back side or the front side from us, and you see these are the switches. They are like in a comb shape. Looks like a parallel plate actuator, and using MEMS technology. So when you actually press these buttons actually through the keypad, and this black circles, they are touched to these surfaces, and there is a short circuit between these parallel lines. Now there is no connection between them, but once you press this switch from this side, this black makes the short circuit amongst them, and that's how that PCB tracks then makes the connection and all that. It's quite smart. There is some different pattern here. There is a twisted one. Here is a different pattern, but the rest are same. And what this button, this is like, you see for the OK button there is a different pattern they have given, and for this twisted there is a buy. So is a bit here is also for the pin number 7, button number 7, there is this twisted pattern. So it's quite interesting stuff we have explored. Is there anything beneath the display? Not really, nothing. There's that space is empty, not empty, but there are PCB tracks there. Okay, so hope you enjoyed this video. If you did so, like, share, subscribe to the video channel, and share this video with others. Wish you all happy learning into modern electronics.